In number 23, they're asking you to evaluate an integral here of x over the square root of 1 plus x, all taken with respect to x. Now, they were nice enough to tell you straight out to go ahead and use u substitution and even tell you what the substitution is. This is still kind of a tricky problem, though. So here's what I would do. Off to the side, I'd always write my original substitution. U is equal to x plus 1. And that means that our primary substitution is going to come from the denominator right here. So this integral now is going to be the integral of, and down in the bottom of this fraction, the square root of x plus 1 now just becomes the square root of u. That's our primary substitution. But our secondary substitution needs to encompass this product right here of x times dx. And in simpler u substitution problems, we can get that just by taking the derivative of this u equation right here. So, although in this case it's going to be a little bit funny, anytime you let u equal a linear function, you get this kind of basic statement here that du is just equal to dx. That's it. So that takes care of this part right here. All right, that dx at the end now just becomes a du. That's not shocking. But we still need to take care of the x up here in the numerator. So once in a great while, guys, we need to take our u statement, u is equal to x plus 1, and go the opposite direction with that. And in this case, we need to solve it for x, which we'll do by subtracting a 1 from both sides, and we'll get x is equal to u minus 1. So the numerator right up there, now which was a monomial of x, now becomes a binomial of u minus 1. Now, this covers the full substitution right there, so that's great. But my guess would be that out of all of us who did this problem, and we did not do great on this as a class, out of all of us who did this, I would bet a lot of you guys got this far and then still had some trouble evaluating the integral. So where are we going to go from here? Well, what I want to point out here, guys, and this might be helpful for future problems that look like this, is that this type of substitution problem is basically a trade. It's a swap. Look at what we had in the original integral, everybody. It was a monomial on the top and then the square root of a binomial on the bottom. And look at where we are now. We have a binomial in the numerator and the square root of a monomial in the denominator. Now, that might not seem like a really big deal, but it is, guys. Getting the square root of a monomial opens up some doors that weren't available to us when we had the square root of a binomial. So a couple of ways of explaining where we're going right here. What I would probably do is split this numerator and make it u over the square root of u minus 1 over the square root of u. So I guess if you need to write that out, or if it helps to see it, guys, it would look like this. U over the square root of u minus 1 over the square root of u, all with respect to u. And now I'm going to go ahead and simplify each of those fractions. Whoop, whoop, whoop. Here we go. So the integral of, remember, guys, this is u to the first, and this is u to the 1/2 power if I ignore that radical. Subtracting those exponents, 1 minus 1/2, gets me a u to the 1/2 power for that first term. Now, the second term can't really be simplified at all. It's just 1 over the square root of u, but I'll rewrite that as u to the negative 1/2 power, all taken with respect to u. And now we've got everything on one line. Now we can just use the power rule here in reverse to antidifferentiate these two terms. So the antiderivative of u to the 1/2, that's going to become u to the 3/2 power. Dividing by 3/2 is multiplying by 2/3. There you go. And then minus this u now, we raise its power by 1, that becomes a positive 1/2, and dividing by 1/2 is the same as putting a 2 in front of that. Okay, that was an indefinite integral, so we'll need to put a plus c at the end of all that. And now really all we need to do is get rid of those u's and go back here. Oh, I take that back. Actually, I'm sorry. I went way too far with that one. All I needed to do here, guys, was to look at which of the 4 options right here would be a valid form for the integral. So I didn't even need to do that. I certainly don't need to do what I was about to do. Let's take a look at what we have right here, guys. I should have read my directions more carefully here. So which one are we dealing with? And it looks like, yeah, almost exactly. We're talking about C here for problem number 23. The integral of u to the 1/2 minus u to the negative 1/2, all taken with respect to u. So it looks like our answer for number 23 is C.